Welcome to our day 10 discussion. Today we are going to discuss about the services in Kubernetes. Let's do a quick recap what we have discussed in our day 9. In our day 9 class we discussed about the replica set. Okay, so what was the purpose of replica set? To make sure a specific number of pods are always running. If I'm creating a replica set, okay, and I'm saying like, okay, I want to have 3 pods, then 3 of the pods are going to be created. And if I'm going to update from 3 to 1, then 2 of the pods are going to be deleted. And this process of scale in, I would say scale in and scale out, we are able to achieve using replica set. As I have mentioned, today we are going to discuss about the services in, I would say, services in Kubernetes. So firstly, we need to understand why we need services in Kubernetes. I would say till now what we have done, we have created a replica set, and then this replica set was basically responsible to create multiple pods. I would say this is my pod number 1, this is my pod number 2, and this is pod number 3. And I have deployed the application inside the pod number 1, 2 and 3. So at the user end, okay, at the user end, I need a single point of entry. So for that case, what we need to have services. Okay, so the service will have its own IP and we are good to share this IP with user, and then the service is going to interact with my replica set, and finally my replica set is going to interact with my pods, and it would be the responsibility of my services to distribute the work, I would say work load. It will make sure if my this user is sending a request, it will come to P1. I would say if another user is trying to interact with my service, it will come to P3. In the same way, it will make sure our traffic is well distributed among the 3 pods. If I'm going to scale in from 3 to 2, it will make sure the pod, I would say the pod 1 which has been deleted, it will not send the traffic to here. It will distribute the workload between the pod 2 and pod 3. So the next question comes, what are the different types of services? So in Kubernetes, I would say services, we have 3 types. The first one is called ClusterIP. The second one is called as NodePort, and the third one is called as LoadBalancer. While the ClusterIP and the NodePort are the inbuilt services of Kubernetes, and the load balancer is generally provided by our cloud vendor. So let me firstly focus on ClusterIP, then we are going to discuss about the NodePort, and then we are going to discuss about the load balancer. So the first one which we are going to discuss is ClusterIP. The first attribute of ClusterIP is it is reachable within the cluster. So what is the exact meaning of it? I would say we have 3-tier architecture. The first one, it would be front end. I would say the second one, it would be back end. And the third one which we are going to have, it would be our database configuration. So in front end, I would say we have 3 pods, pod 1, pod 2 and pod 3. In the same way, in backend, we have 3 pods, pod 1, pod 2 and pod 3. And finally, in our database configuration also, we have 3 pods: pod 1, pod 2, and pod 3. So it would be the responsibility of service to connect the front end and back end. The connection, it would be all the pods are going to connect with my service, and then the service is going to interact with my backend pods. In the same way, for the communication between the backend and the database, what we need? We need a service. Okay, what we need? We need a service, and for my backend pods are going to connect to my service, and then this service is going to connect with my database. I would say database pod. So do you think the connection between the front end and the back end, does it require any public IP? The answer is no. And for the backend and the database configuration, do you need any public IP? The answer is no. So in this case, what we are good to use? We are good to use the cluster IP. Okay, we are good to use the cluster IP services, and it would be the responsible of the cluster IP services to distribute the workload between the backend ports and for the database ports, and it will provide a single point of contact to connect the backend, and same from backend to database. So if you want to connect the front end to the backend, we are good to use what? Cluster IP. In the same way, if you want to connect the backend and the database, we are good to use the cluster IP, and it is going to provide what? It is going to provide the private IP only. So for the lab purpose, what we are going to achieve, first step, we are going to have our replica set, and the replica sets are going to create a pods for us. And once this replica set is created, I would say the second one, it would be cluster IP. Okay, and using this cluster IP, we are going to connect to our pods. So in terms of diagram, it would be something like this. We have our replica set, and this replica set, I would say, have 4 pods: pod 1, pod 2, pod 3, and pod 4. And then we are going to expose this replica set using cluster IP, and then cluster IP will provide one IP to us, and it would be private. So we are good to access this IP within the cluster only. I would say when we are going to ping on this IP, sometime we'll get the response from the P1 or from the P2 or from the P3 and from the P4. So in the round robin fashion, we are going to get an input from any one of our pods. So let's do a quick demo. So for this class, I have already created a cluster name called as demo-aks. Okay, let me quickly connect to my cluster. I'll click on set the cluster subscription. We'll open the CMD, copy the command. Then I will download the cluster credential. Okay, let me open the Visual Studio Code. So as I have discussed, the first thing which we are going to create is our replica set. Once my replica set is created, I'm going to create what? A cluster IP, and then this cluster IP is going to provide me a private IP, and using this private IP, I will connect to the pods which are created inside my replica set. So the first file which I'm going to create, name called as ecom.yml, and let me paste the YAML configuration. If you see here, the kind is replica set and the name of my replica set is e-commerce. How many pods we are creating? We are creating 5 pods, which means pod 1, pod 2, pod 3, pod 4, and pod 5. 5 pods are going to be created. Firstly, what we have mentioned selector. It will firstly filter if we have any pods present with this label. If it is not present, then what it is going to do, using this template, it is going to create the pods for us. Okay, let me quickly copy the path and run a command called kubectl create -app ecom.yml. See, it has been created. Let me run a command called kubectl get rs. So 5 is desired and the current is 5, and we do not have any pods in a running state. Let me run kubectl get pods. So all 5 of my pods are in running status. Let me run again kubectl get rs. So currently, if you see in my replica set name called as e-commerce, the desired 5 pods, the current 5 pods, and the ready are 5 pods, and the age is 28 seconds. Okay, let me run a command called kubectl get pods -o white. There's one typo, kubectl get pods -o white. If you see here, kubectl get pods -o white, each pod has its own IP. So what is the meaning of it? Pod number 1 has its own IP, pod number 2 has its own IP, and same for pod number P3, P4, and P5. Okay, so what I have done here, I have created one virtual machine. Okay, if you see this virtual machine name called as demo-aks-vm. Okay, and this one created inside the same VNet in which we have created our AKS clusters. So AKS-subnet, I have created my AKS cluster, and in VM-subnet, I have created my, let me log in this virtual machine using this IP. I have already logged in, so it is not going to ask me the username and password. So I'm directly logged in. So let me log in this virtual machine. So I've already saved my user ID and password, so it is not going to ask me the user ID and password. Okay. So I'll open this Edge browser. So if you see here, what we have 5 IP address. So let me copy this IP address and paste it here. So the pod name is 4x. Let me copy the second IP, and this one is pointing to BXK94 pod, and the same way we are good to check for the third and the fourth one. So if you see here, what we have done, we have created our replica set, and this replica set has created 5 pods: pod 1, pod 2, pod 3, pod 4, and pod 5. Each and every pod has its own IP. Okay, so in real time scenario, do you think we are going to share this pod IP address to the end user? The answer is no. Why? Because as we have discussed in our replica set video, we are good to scale in or scale out our workload, our pods according to our workload. So what we need a single IP. So for this configuration, we have one service called ClusterIP IP. What cluster IP is going to do? Cluster IP is going to connect to my replica set. It will provide a single IP. And this IP, it would be private IP only, and which is reachable within the cluster. So the next step which we are going to do, we are going to create our cluster IP. Okay, let me minimize this one. So I'll create CIP hyphen ecom dot YML. I'll paste here. As you can see here, the kind is service and the name of my service is CIP hyphen e-commerce and the type is cluster IP. You see here what we have mentioned, label app colon e-commerce. The same thing we have mentioned in selector. So what this service is going to do, the service is, I would say my cluster IP service is going to look for this label and it will find out this replica set which has 5 pods, pod 1, 2, 3, 4 and 5 and it will be bind. Okay, and then it is going to provide me a single IP and using this IP when I'm going to curl, so we will get a response from any of this pod. So let me quickly create the cluster IP service name called as CIP e-commerce. So the command is kubectl create hyphen f CIP hyphen ecom dot YML. And if you see here, it has been created. kubectl get svc. The name of my service is CIP e-commerce. The type is cluster IP, the one which I have mentioned, and the IP is this one. Are you able to see any external IP? The answer is no. So whenever we are going to create our cluster IP, it is not going to provide any external IP. So what we need to do, we need to create a pod inside this node. I'll open a new CMD. So what I'm going to do, as I mentioned, I'm going to create a pod to log in inside this node. Let me press enter. So what it is doing, it is creating a debugging pod which would be created inside this node, and see right now we are inside this node. The first command which I'm going to run, apt hyphen get hyphen update. There is one typo, apt hyphen get update. Then we need to install curl apt hyphen get install curl. And this next terminal, if I'm going to run kubectl get pods, so there is one typo, kubectl get pods. If you see here, we have one pod running name called as node debugger, which is running inside this node. So it has been done. Let me quickly clear my screen. I'm going to mention curl. We'll copy the cluster IP and let me press enter. If you see here, we are not getting any response. Why? Because we have not mentioned the port number. So basically what we have done, we have exposed two ports, one at the pod level and the second one is at the cluster IP level. So at the cluster IP level, what I have mentioned 5000. So I have to mention the same one, colon 5000. Let me press enter. So it is pointing to BXK94 pod, which is the second one. If I'm going to curl again, it is coming the same pod. Let me try it again. So right now it is coming 4xf pod. So this one is the first one. So in the round robin way, it is going to transfer the traffic between our pods. See, it is coming kw, which is our third pod. So what we have achieved in this demo, the first thing which we have created is our replica set, and then the replica set has created 5 pods: pod 1, pod 2, pod 3, pod 4, and pod 5. And then the replica set is connected to my service name called as ClusterIP e-commerce one, and it has given what? It has given me a private IP. And using this private IP, whenever I'm doing curl, I'm able to get a response from one of my pods. The limitation of cluster IP is it is reachable within the cluster only, which means if I'm going to copy this IP and paste inside my Windows Chrome browser, we will not get a response because this one is a private IP. Okay, so to overcome this issue, what I have done, I have created a node debugger pod. Okay, and this pod is created inside this node, and I have logged in inside this node, and using a curl command I'm able to see all the pod history. If you see here, this one is the first cluster IP which I have created. The second one is created in built while creation of my AKS cluster. So Kubernetes also uses the cluster IP service to distribute the workload inside the cluster. Let's discuss the second type of Kubernetes service called NodePort. Okay, let me quickly clean my screen. So the second type of service which we are going to discuss is called as NodePort. Why it is called as NodePort? Because at the node level, I would say at the node level, we are going to expose the port. That's why it is called as NodePort. Let me quickly draw a diagram to explain it. I would say I have two nodes, okay, node 1 and then node 2. This is my node 1, this is my node 2. What we have done, we have created a replica set. Okay, what we have done, we have created a replica set, and inside this replica set, I would say inside this replica set, what we have n number of pods. The pod 1 which is present inside the node 1, pod 2 which is also present inside the node 1, and we have pod 3, pod 4 and pod 5 present inside the node 2. So what we have, this one, this is my replica set, and inside the replica set what we have 5 pods running. Then the second thing which we are going to have is our cluster IP, and it would be the responsibility of my cluster IP to connect with whom? With my replica set, and the replica set will connect with my pods. Then what we need to do, we need to expose the port at the node level. What we have to do, we have to expose the port at the node level, and then this one, it would be connected to my cluster IP. And so at the user end, what we need to mention, we need to mention the IP of the node colon the port number on which we have exposed our each node, and the range of this port is, I would say, 30,000 to 32,767. We are good to mention any number within this range. If you see this one, what we have at the multiple node level, this is my node 1, This is my node 2 and I have created a replica set, and we have five, five pods running for this replica set. And then we have our cluster IP node port, and finally using the IP of my node and the port on which number we have exposed, we are good to access the application. Let me create a diagram which is specific at the node level. So it would be like this. What we are going to have, we are going to have this node, I would say node 1. Okay, in this node 1 we are good to have one pod 1. Then we are going to have service, and then finally at the node level we are good to expose the port. Okay, so the port which we have exposed at the pod level, it would be called as target port. Okay, and the port which we have exposed at the service level, it would be called as port. And then finally the port which we have exposed at the node level, it will be called as node port. That's why this service is basically called as NodePort, because at the each node we are exposing the port. Okay, and the traffic flow will like this. We are good to mention the IP address of this node, colon the port on which we have exposed our node. Then it is going to connect to the service, and then the service is going to connect to my pods. Let's do a quick demo to implement it. Okay, so I'm going to create a file name called as nodeport.yml. As you can see here in this YAML configuration, we are creating a service, and the type of the service is NodePort, and the name of my service is e-commerce outside app. Here we have exposed three ports. I would say this is my node. Okay, so in this node, the first one which I have exposed at the pod level, at the pod level, it is called as target port. Then it is connected to my cluster IP, and this exposed port is called port only. And then finally at the node level we have exposed a port which is called as node port. And as I have mentioned earlier, we are good to mention any number within this range. So let me run this YAML configuration. Okay, so what we are going to do in this configuration, we are going to use the same replica set which we have created initially, ecom.yml. Let me quickly delete this cluster IP configuration YAML. So I will run a command called kubectl delete -f cip ecom.yml. So it has been deleted. I will run a command called kubectl get svc. So cluster IP service is not showing. I will run a command called kubectl get replica set. We have our replica set name called as e-commerce, and let me quickly run the kubectl get pods. So currently we have the 6 pods running, 5 from the replica set and another one is from the node debugger. I will run a command called kubectl get svc. Okay, let me create a file name called as kubectl create -f nodeport.yml. Let me run a command called kubectl get. If you see here, our e-commerce outside app service has been created. The type is NodePort. This is my cluster IP service. This is basically an external IP, and these are the ports on which we have exposed our NodePort service. So what we have to do to access this application, this is my replica set which I have created. Then I have created what? A node port. So to access the application, I have to mention the node IP colon the port on which we have exposed our node port. So we have mentioned what? 3000 and 3. So to get the IP, I'm going to run a command called kubectl get nodes -o void. Okay. As you can see here, we do not have any public IP, but what we have the internal IP. I'm going to copy this IP. It's present inside the same VNet. So I will copy this one. I will paste the node IP and then the port on which it has been exposed and press enter. See, we are able to see our application. And if I'm going to refresh it again, it is going to different pods. We are good to say in our replica set pod 1, pod 2, pod 3, pod 4 and pod 5. And by mentioning the node IP and this port, we are able to access any one of the pods. So this is the second type of service which we have discussed. Okay. So let me quickly copy the internal IP of second node 2. Okay. Colon 3003. See, from both the nodes, we are able to access our application. So this one is called as NodePort. So the third type of service we are going to discuss is called as load balancer. It is provided by the cloud platform and it works on the layer 4. So till now what we have done, we have created a replica set. In the first example, we have exposed our application using the cluster IP, and in the second example what we have done, we have used NodePort. The cluster IP is used for the internal configuration only. The node port in our example, at the node level we have exposed the port. Okay, our node, what I have done, the node was having only private IP, but in the real time scenario the node port is not recommended. Why? Because to access the application we have to mention the IP of our node and then we are exposing the port at each of the node label. So to overcome this issue, what we need to use? We need to use a load balancer. So our load balancer is already created once we created our AKS cluster. So using the kind load balancer, we are good to use, I would say, the load balancer type. So let me do a quick demo to understand it. Okay, so let me run a command called kubectl get svc service. I will run a command called kubectl delete -f nodeport.yml. Let me run again kubectl get svc. See, so I'll create a YAML file name called as lb.yml. As you can see here, the kind is service. Right now, what I have mentioned type as load balancer. This is my target port which I have exposed, and this is the port number. This is the selector which I have mentioned to connect with my replica set. Okay, let me run this YAML configuration kubectl create -f lb.yml. My load balancer has been created. I'll run kubectl get svc. So my external IP is pending. I'll mention -w. So finally, what we have a service name called as lb-ecommerce. The type is load balancer. The cluster IP is this one. And finally, we have the external IP. So what is the meaning of this one? We are good to say this one is a public IP. and using this IP, we are good to connect to our application. So till now what we have done, to access our application, in the first case, I have used the node and then I have login. In the second case, what I have done, I have created a virtual machine in the same VNet in which we have our AKS cluster. In the third case, as it is the public IP, I will log in from my browser, which is not inside the network, and then we'll try to check. So I'll copy this IP, open the Google Chrome, and it's not part of my network. I'm running it from my local machine. See, currently we are getting a request from QV781 port. The second one is RG2 and 4X. So eventually what we have done, we have our replica set, and then this replica set is connected to the load balancer, which is a layer 4 load balancer, and this load balancer has provided us a public IP, and using this public IP I'm able to connect all the ports which are present inside my replica set. Okay, so this load balancer has done what? It has created external IP. Let's take a scenario where we want a private IP on. So for this use case, what we have to do, we have to add one annotation. Let me quickly create a file name called as internal-lb.yml. As you can see here, I'm creating a kind service. The type is load balancer only. I have exposed the two ports, and the selector is app colon e-commerce, which is going to connect to my replica set. But here I have mentioned one annotation, and you can see here Azure hyphen load hyphen balancer hyphen internal. What I have mentioned here, I have mentioned here as true. So if we are going to use this annotation, then we are not going to have the public IP. What we are going to have? We are going to have the private IP configuration. So let me quickly run this YAML configuration and show you. Okay, let me delete kubectl, delete -f lb.yml. It has been deleted. Let me run kubectl create -f internal -lb.yml. Let me run a command called kubectl get svc. It is showing pending. Let me run it again. Still it is showing pending. I'm good to mention -w. It will take around 30 to 40 seconds to reflect the IP. So finally, what we have one IP, and this is a private IP address. From where we are getting this IP? We are getting this IP from the subnet which we have created for our AKS cluster. Let me show you quickly inside my portal. If you go inside this subnet, so this is a dedicated subnet which I have created for my AKS cluster, and if you see the range of this one, it is coming from this IP only. If I'm going to copy this IP and paste in the browser, which is from my local machine, do you think it would work? The answer is no. So what I have to do, I have to log in inside the virtual machine which is present inside my same VNet. Paste it here and I will enter. See, we are able to connect my application. So what we have done in this example, we have created our load balancer, but this load balancer is a internal one only, and due to this internal load balancer we have private IP, and using this private IP we are able to access the application but within our network only. Okay, so let's do a quick recap what we have discussed in this video. We have discussed about the services in Kubernetes. We have three types of services. The first one is called as cluster IP. So cluster IP is going to provide me private IP only, and this is the inbuilt service of Kubernetes, and it is used for the internal communication only within the cluster. The second one which we have discussed is the NodePort. So in this NodePort, what we are doing, we are able to access the application, but we have to mention the IP address of our node and colon the port on which we have exposed our node. And this one is not recommended in real-time scenarios. We need to mention the IP of our node, and then we need to expose the port to. So it is used in lab environment only. Then we have discussed about the third type of service called load balancer, which is provided by the cloud platform. I would say our Azure. While creation of our AKS cluster, it is automatically created. So this one, what we have this. So what we have done, we have created a two types of load balancer. One it is called public load balancer, and the next one it is called as private load balancer. In both the cases, what we have mentioned, the type, I would say the type is load balancer, but in case of private, we have mentioned the annotation of internal, and then the IP which we got, it was a private IP, and we are able to access our application within the network only. So with this, we have completed our services discussion. So thanks a lot for watching the video.